Good morning to everyone. Today we are going to discuss about force and pressure. In science, a push or pull of an object that is known as force. The interaction between two objects arises the force. The force that is a vector quantity, it have both magnitude as well as direction. The strength of a force that is expressed in magnitude, that if a force is strong, it means it have large magnitude. Force brings about a change in the direction or the state of motion or the state of rest. So here we are going to discuss about the effect of the force. Force can change the direction of motion, force can change the state of rest, force can change the direction, force can change the shape and size of the object. So here are here are four or five effects of forces which we have discussed. Here you can see pressing the switch, kicking a wall, launching rocket, knocking a nail, and pushing trolley. These all are the example of the force. Here's an external agent that is applying the force, as in the first example, that pressing the switch. When you are pressing a switch, it means you are applying the force on the switch. Similarly, when you are kicking a wall, it means you are again exerting the force by your foot on the wall. Similarly, launching the rocket, knocking a nail, and pushing trolley, all are the example of exerting the force on particular object. Now here on the screen you can see the force. What is a force? Force is a push or pull, or we can say it both. Force cannot be seen, what we can feel and observe the effects of the force. So here are types of the forces. Here are two types of forces. You can see here push and pull. There are two types of forces. So what is push and what is pull? So push, that is a force to move an object away from our body. As when we are pushing the trolley, this is the example of push, and when we are dragging something to by any rope, that is the example of pull. And a pull is also a force which move an object towards our body. It means in simple words we can say that when we are moving when we are applying the force on body, then if body moves away from our body, away from us, then that is the push. And if we apply the force on object and object moves towards us, towards our body, then this force is called pull. Now combination of push and pull, here you can see playing a guitar. In that we are pulling and pushing the wires of the guitar and scrubbing the floor when you are scrubbing, and sawing the wood, rowing a boat. Then in that process we are applying both the forces simultaneously. Now next one, now the introduction of the force, effects of force. Friction, that is again a type of force that is known as friction force. When we are pushing or pulling an object on the rough surface, then that force, friction force, comes into play, and which opposes always the relative motion between the objects. Here you can see in this diagram a man that is pushing the block and another man that is pulling the same block. This is the example from where you can clearly see that what is a push and what is a pull. Now another example, that is a magnet. In first case there is attraction between the opposite poles, one north pole, the another one is south pole, and here repulsion between the similar kind of forces, and here is rotation because of de-alignment of poles of the magnet. Now force and pressure. We have discussed about what is force that is push or pull, and how the force affect the state of rest or state of motion of any object, and we have discussed how the force change the direction of motion of any object, how the force changes the shape and size of the object of any object, and we also discussed about the force have magnitude and direction both. That's why force is a vector quantity. And what is the SI unit of force? SI unit of force, that is Newton. Now you can see here the types of forces. In the types of forces here, the forces are of basically two types: contact force and non-contact force. Contact force, in case of the contact force, means when two bodies are comes in contact with each other, then the force applied by one body on another, that is the contact force. Like muscular force, when we are applying the force on any body via our muscles, like dragging the water from the well, drawing the water from the well and dragging any block, or kicking the football. These all are the example of muscular forces. Now another one is friction force. Here you can see this is muscular force, this is friction force. Friction force, the force which is responsible for changing the state of motion of the object, that is called friction force. It always acts on all moving object in the direction opposite to that of the motion. Means if object is moving in forward direction, then always friction force opposes its motion, means it always acts on that object in the opposite direction. That's why friction force always opposes the direction of motion. Here you can see in this diagram that direction of motion is in this direction, and friction force that is applied in opposite direction. So this is the example that when we are moving on the on a surface, on any floor, then in that case friction force opposes the direction of motion. Now you can see here another type of force, that is non-contact force. Non-contact forces are of three types: magnetic force, number one magnetic, then electrostatic force, then gravitational force. These all are the non-contact force, means there is no requirement of physical contact. Like in magnets, we have discussed earlier, you can see here these are the magnets, and there is no requirement of physical contact. One magnet is placed here, it have two poles, north and south. Another magnet is placed here, it also have the north and south pole. So these are not in contact, but here is a force acting between these magnets. Like this, you can see here, if the opposite poles are facing to each other, then there is attraction. If similar forces are facing, poles are facing to each other, then there is a repulsion between the poles. Similarly, another force, that is electrostatic force, another type of non-contact force, that is electrostatic force. This force acts between the charge bodies. When two bodies are charged, whether they have like charge, like means similar charges. When they have similar charge, then there is a repulsion, and when they have opposite charges, then there is attraction. Basically, charge is of two types: positive charge and negative charge. Plus, this is symbol of charge, plus q and the minus q. If here you can see there that one charge is positive, another charge is negative, then there is a force of repulsion or attraction. This is the force of attraction, because here the force of attraction between the two charges, because both charges are unlike charges. One charge is positive and another charge is negative. Now if both charges are of same type means one charge that is positive, another charge that is also positive, or we can say one charge is negative, another charge is also negative, then there is force of repulsion acts between these similar charges. Such force that is known as electrostatic force. Now gravitational force, another type of non-contact force, that is gravitational force. So what is a gravitational force? Gravitational force, that is the attraction of objects towards the earth, known as force of gravity, or we can say that whenever two masses are placed in close contact, then there is a force acts between them, that is gravitational force. Or from the Newton's law of universal law of gravitation, every object in this universe acts attractive force on other objects, that is the gravitational force. Here on this planet, every object on this planet experiences a pull of the earth towards the center of the earth, that is the gravity, that is the force of gravity. This force acts on all objects in the universe. Every object in the universe, whether small or large, exerts a force on every other object. This is explained by Newton. That's why here is a law that is known as Newton's law of gravitation. Now another fundamental quantity, physical quantity, that is pressure. What is pressure? What is pressure? Pressure is nothing. This is force acting per unit area. Force acting per unit area, that is pressure. Force acting per unit area, that is pressure. Now here you can see on the screen, this is the formula of pressure, definition of pressure, that is force acting per unit area, or we can say that force per unit area applied in the perpendicular direction of the surface of an object is force equal to pressure equal to force upon area. Now it is also can be defined as thrust acting per unit area. Now here you can see in this diagram that a nail that is pressed in the wooden block with the finger, with the thumb, this is the example of the pressure applied on the block per unit area. From here, by the finger we are applying some force, and here there is some area of the nail, that is area, suppose that A, then pressure comes out force per unit area, that is F upon A. If I take the example that value of force is 2 Newton and area is 1 meter square, then what will be the value of pressure? That is 2 upon 1. 2 upon 1, that is 2 Newton per meter square. Newton per meter square. Okay. What is the SI unit of pressure? From the formula that pressure equal to force upon area, the SI unit of force is Newton and SI unit of area that is meter square. So SI unit of pressure is Newton per meter square. Here are some examples of application of pressure. There are some applications of pressure. Here you can see there are some applications of pressure. That is the pressure equals to force upon area, factors affecting the magnitude of pressure, magnitude of, that is, we can see here that in the formula we have pressure equal to force upon area. So value of magnitude of force and magnitude of area both affects the magnitude of pressure. Now SI unit of pressure, that is Newton per meter square or Pascal. Newton per meter square or Pascal. There are some other units like atmosphere to measure the atmospheric pressure. Application, here you can see applications of pressure. The first application, that is sharp knife. The edge of the knife that is sharp means the area of the edge of the knife that is very less, so that if area reduced from the formula of pressure force upon area, now if a value of area is less, decreased, it means pressure increased. That's why by the sharp knife we can easily cut the vegetables. Then the other knife whose edge is not, the edge of the knife that is not sharp. Another example, another application of pressure, that is shoe with spikes. As we can see that the shoes of footballers and cricketers, in those shoes there is a sharp spikes, and the area of the spikes that is very less. That's why the large pressure can be produced. Area is less and value of the pressure will be large. So that's why these spikes hold the ground very tightly, and it helps to cricketers and to footballers to run very easily without any slipping. Thank you. Have a good